Okay, guys, I just accidentally paused the video because my elbow hit the keyboard so I don't want to start all over, I'm sorry. I just drew the slope field. So I already had these filled in when the video started, and then I did the slope field for the corresponding points. So if you have any confusion on how I got these little slopes, just let me know. Yeah, and in the video I showed so the slope at this point, -1, 3, I did little dots. I went up to right 1, and then I drew the line. And then this one had a slope of 1 at this point, so I went up 1, right 1, and then I drew the line. And then this one had a slope of -1, so I went down 1, right 1, and then I drew the line. So I just did little dots to do the rise over run, and then I drew the line. So that's how I got the relative steepness. Okay, part B. While the slope field in part A is drawn at only 12 points, it is defined at every point in the xy plane. Describe all points in the xy plane for which the slopes are positive. So we want dy dx to be greater than 0. So I'm going to think about cases here. So x squared y minus 1 greater than 0. That's what I want. Notice, guys, how we have two factors. So you want to think in terms of like positive times positive, negative times negative. Those would both give you positive slopes. So basically, these two factors, if they have the same sign, then their product is positive. If they have opposite signs, then their product is negative. We only want positive slopes. So I've got to ask myself, when is this product going to be positive? Okay, so this is going to happen if x squared is greater than 0 and y minus 1 is greater than 0, or if x squared is less than 0 and y minus 1 is less than 0. Guys, x squared, this will never happen. That's never going to happen. So we need x squared greater than 0 and y minus 1 greater than 0. Guys, this is always true for any x that's not equal to 0. So if x could be 0, and then that would be 0. But if x is any other number, you square it and it's positive. And then over here, this is true for y is greater than 1. You just add 1 to both sides. So here's the answer. So the answer is for all x, y, and then you have to describe the x and y. For all x and y where x is not equal to 0 and y is greater than 1. Okay. Now part C, so this is the only part that's kind of different than the previous problems we've done. Now for part C, I'm going to find the particular solution to the given differential equation with the initial condition f of 0 is 3. Okay, so I'm just going to run through this. It'd be a good exercise, guys. I know this is just like the lesson video, but if you tried to go ahead of me, that'd be a good exercise. So this is part C. So dy equals x squared y minus 1 dx. But I could like cross multiply. Now I need this to be over here, so I'll divide. So 1 over y minus 1 dy equals x squared dx. And then you do the antiderivative. Now this here, let me make sure, let's see if this is f prime over f. So f is y minus 1, f prime equals 1. Yeah, so this is f prime over f. I'll use a different color. Yeah, so I've got f prime and f. So the f prime over f formula says that that antiderivative is natural log of the absolute value of y minus 1. And the antiderivative here is a third x cubed plus c. Now we need to find c. So we're going to use f of 0 equals 3 to find c, dot, dot, dot. So I'm plugging 0 in for x and 3 in for y. So 3 goes in for y, so that's natural log absolute value of 2 equals 0 plus c. C equals natural log of 2. Now, I don't need the absolute values, guys, because 2 is already positive. So I change them to parentheses. Okay, so now you plug the c back in. So natural log of y minus 1, absolute values, 1/3 x cubed plus natural log of 2. Okay, then I'll put a base of e on both sides. So these will cancel. So those will cancel. So we get absolute value of y minus 1 is e to the 1/3 x cubed plus natural log of 2. Then, to drop the absolute values, you've got to go plus or minus this 1/3 x cubed plus natural log of 2. Okay, now we've got to decide if it's the plus or the minus. It can't be both. So we're going to use initial condition. So aside, we want f of 0 equal to 3. This is what we want. All right, so when we plug in this x, we need that y. So we're going to figure out if it's the plus or the minus one. So 3 minus 1 equals e to the natural log of 2. 2 equals 2, check. Now we'll do, and then the negative one wouldn't work. So if you did 3 minus 1 equals negative e to the natural log of 2, you'd get 2 equals negative 2. That's not the case. That is not the case. Yeah, so it's the positive one. So y minus 1 is e to the 1/3 x cubed plus natural log of 2. So we get y is e to the 1/3 x cubed plus natural log of 2 plus 1. Okay, there it is.